Yeah, it's working. We're recording. See? Second try. Perseverance is key, guys. All right. Example 5, expand in one fell swoop. Now, what does one fell swoop mean? Yeah, in one step. Right, in one step. So we're not going to do in 2 fell swoops, one fell swoop. Now, here's the idea behind expanding in one fell swoop. Remember the properties of logs that we looked at on Friday. And very quickly to review. The log of a product becomes the sum of the logs. Okay? So each factor gets its own log, and they're both positive terms. The log of a quotient becomes the difference of the logs. And now the sign matters. The numerator gets its own log, but it's a positive term. And every factor in the denominator gets its own log, but is a minus, is a negative term. And then my favorite one, the log linearizes exponentiation. So constant multiples come from exponents on the argument's factors. So the natural log of a raised to the b's power, you can bring the b out front and call it b times the natural log of a. All right, so to expand, here's the idea. You want to first go through and take inventory. How many factors do we have? Well, I have the factor of 5, so that's my first factor. I have a factor of x squared, so that's factor number 2. And then I have this wonderful factor right here, which I'll call factor number 3. So, yes. Yeah, I'm going to treat, because they're 2 different types of factors, right? 5 is a number factor, and x squared is a variable x factor. Now, you could normally just consider 5x squared as being like a single factor that's a polynomial term. But for expanding, we want to consider them as separate. So 3 factors in the numerator means each of those is going to get their own log, and they're positive or negative terms. Positive, good. Now, let's take inventory in the denominator. How many factors do I have down there? Similarly, the 2 is a factor, so that's the 4th. And by the way, if you want to simplify first, can 5 halves simplify? No. If that had been like a 6 halves, you'd have the option of just calling it a 3. And that'll eliminate one of the factors. But 5 halves is irreducible because 5 and 2 are co-prime. There's no common factor other than 1. All right, so y is another factor. That's factor number 5. And then we have this wonderful radical factor, which I'll call factor number 6. Okay, so 3 factors in the denominator means they each get their own log base 7, but they're what sign of the term? Negative. So 6 factors total means I'll have 6 terms. 3 are going to be positive, 3 are going to be negative. Now, the last thing you do when you expand is you bring the exponents of each argument out front. So here's how we're going to do it in one fell swoop. Starting a little bit more to the left, because you're going to need some room, we're going to have log base 7 of the first factor, which is 5. And by the way, I just naturally start in the top left and go left to right in the top and then left to right in the bottom. But remember, because multiplication and addition are technically commutative, you can do them in your favorite order if that's different from what I'm doing, as long as the signs are okay. All right, the next term has an exponent. So here's what I would recommend. Temporarily, otherwise you'll be able to do it in one step. But go plus and leave a little bit of a space after the plus sign and write log base 7 of x. Now with notability, I'll do it one time. I'm going to write my squared right there. And you can animate this with notability. Where would that exponent go now? It goes out front. So watch this. You can lasso it with scissors, and using the property, right there. Sweet. Nice. So that second factor becomes plus 2 log base 7 of x. And I'm not going to show you the animated version anymore. We're just going to write it like that. The next term, plus. Leave a little space after the plus sign, maybe more than that. Log base 7 of. The argument, then, is the quantity 2y minus 1. If you were to write the cube root of 2 minus 1 squared as 2 minus 1 to what power, what would that power be? Well, it's already squared, so it would have to be at least still squared, right? Yeah, it would be 2/3. Because the 2 would stay there. Remember, the cube root puts it to the 1/3 power, which then when you multiply becomes 2/3. So at this point in the game, I am hoping that you can just look at that, the cube root of blob squared, and say it's blob to the 2/3. That's where you should be at this point. And with the 2/3 then as the exponent, it would slide out front and become the coefficient. Now there it is. There's the numerator, completely finished. Okay? And so now I'm going to jump to the denominator. So now the denominator is minus, and we got log base 7 of 2, no exponent, minus again, log base 7 of y to the first, so there's no need to bring the 1 out front. And then finally, we have x plus 1, which is really to the what power? The square root would be x plus 1 to the what power? 1/2, right? So, again, you can just think of that in your head. It's going to come out front, so if you don't want to leave a space, you'll get really good, and you'll just say it's 1/2 log base 7 of the quantity, x plus 1. Now, what if you were hasty at the end and you didn't put parentheses around x plus 1? Is that the same thing? No, because we would read that as 1/2 log base 7 of x plus 1. And so if you have more than one term in your argument, then you have to put parentheses around it. If you have more than one factor, then we'll assume that that first term with as many factors is part of the argument. And there you go. So we end up with 1, 2, 3, 4, 5, 6 terms. Good. And that's it. Now, can we do anything else? Can we combine like terms? Log base 7 of 5 and log base 7 of 2 are both numbers, but can we combine them? No. They would have to be like logs, meaning they would have to be like log base 7 of 5 minus 3 log base 7 of 5. They'd have to both be log base 7 of 5s. And you can't simplify there for the same reason we couldn't divide these out here. They were co-prime. Now, let me ask you this. Can we then distribute this log base 7 of into the x plus 1? Can we call that log base 7 of x plus log base 7 of 1? I don't know. What if I still had the negative 1/2 out front and I distributed it after the fact? Can I distribute a log into its own argument like that? I cannot, actually. This is a big no-no. So you want to simplify, but no oversimplifying. The reason being is now you have the sum of two logs. If you were to condense this right here, it would not condense into that, would it? It would condense into log base 7 of x times 1, right? Which would just be x, which is not x plus 1. So you cannot distribute a log into its own argument. All right, so if you have a log with multiple terms, whether they're added or subtracted, you're pretty much done. But if you have logs of products or logs of quotients, then you can expand, turn them into sums, turn them into differences. Okay, so simplify as much as possible, but don't oversimplify. Questions on that one? In one step, we expanded it. And I do want you to be able to do that. So there's really 3 key ingredients to being able to do that. One word: practice, practice, practice. And then we'll put like an early emoticon, which is the picture of the guy who swallowed a hockey puck. Which is not an emoticon at all. That's the musical symbol for repeat. So practice, 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 and repeat indefinitely until you get really good at it. Okay? Is this also a musical symbol? I don't know. It's a smiley face emoticon. Makes you wonder how emoticons got started. Okay, I'm losing train of thought here. Example 6, condense. Now notice the instructions say in multiple fell swoops. That means more than one step. Although it's pretty easy to expand in one step, it's not always easy to condense in one step. What was the last thing that we did up here when we were expanding in each factor? And you saw that animation in the second term. What was the last thing we did? You want to see the animation in reverse? Yes. Okay. Remember, we gave it its own term. It became log base 7 of x squared. And the last thing we did was what? We bring the 2 out front. So when you're condensing, guess what the first thing you're going to do? If you have a number out in front that's other than a 1 or a negative 1, your first step is to bring it out, or bring it from out front back up as an exponent, okay? Because you're doing essentially the inverse operation. Now, first of all, notice that this right here is not fully expanded. Something doesn't have to be fully expanded in order to condense it. So the first thing I would do is take inventory. How many terms do we have? I have 4 terms. So when I condense it, I should have how many factors? 4. Okay? If you then want to say, okay, I have 2 terms that are negative and 2 terms that are positive. So how many factors then will I have in the denominator? 2. And how many factors in the numerator? 2. Okay, cool. Now, it's not an issue here, but it will be maybe in the next section. In order to condense, your logs have to be the same. And right now, all of our logs are base what? Base natural, right? Base E. That's good. Later on, if some were natural logs and some were like log base 5, we would have to use, I don't know, the change of base formula to get them all the same. But right now, they're all the same. So that's good. All right, so here's the first thing now in this process of condensing. You want to make your coefficients a 1 or a negative 1. So like if you go to the first term down here, it is currently a negative 3. Now you have 2 options. You could, if you wanted to, you could bring the entire negative up there and say it's 2 to the negative 3rd. But then 2 to the negative 3rd is going to be like a 1/8, and then it's going to be an 8 in the denominator. So if it's a negative coefficient, leave the negative there and just bring up the magnitude. That's what I would say. So the 3 is going to have to come up, the 1/2 is going to have to come up, the 2 is going to have to come up, and the last term looks both fine and dandy. It's just a 1. All right, so that first term is going to become negative natural log of 2 cubed, and then minus the natural log of x to 1/2, plus the natural log of. Now notice on this third term, I have the parentheses already around the 3x. I don't really need those there. If I just put plus, or if I just put 2 natural log of 3x, you would assume that 3x is the argument. The first term after a log without parentheses is assumed to be the argument. But notice then, you'd have to be careful, because if you brought the 2 up on there, is that equal to the natural log of 3x squared? No. Okay, it's not, because the 2 is out in front of the natural log of 3x. So this is where it would be helpful to have the parentheses, and now it's the entire argument raised to the second power, not just the x. So having the parentheses there was just kind of a nice little gift. Maybe I shouldn't have done that. But anyway, we talked about it. So it's 3x quantity squared. And over here, it's just plus the natural log of 2y squared. So that's the first swoop. We go through and make the coefficients 1 or negative 1. Now we can start the condensing process. Pull 1 natural log out front. That's how you condense. You get 1 natural log. If you have any negative terms at all, and in here we have 2, you know you're going to have a denominator. So go ahead and build the shelf. And now, any argument that is from a negative term gets multiplied where? In the denominator. And any argument that comes from a positive term gets multiplied in the numerator. So I'll highlight those with red. So you'll have a 3x quantity squared times a 2y squared. And now I'm thinking of Christmas again. Red and green. Now technically we've condensed it. We have the log of a single argument and everything inside is being multiplied or divided. This is where students can get messed up though. They simplify or condense all kinds of wrong. They want to put plus signs in the top and minus signs in the bottom. No, that's wrong. Okay? They also want to like somehow give them each their own log right there. No. Bad. Okay? 1 log out front, they turn into products, either on the top or bottom. Now, of course, that's not completely simplified because the argument can be simplified. So we spent a lot of time in the beginning of the year simplifying expressions like that argument, but without the log in front. So we can go ahead and tap into those skills and show off a little bit here. What is 3x quantity squared? 9x squared, good. Times 2y squared, we'll leave it like that. All over 2 cubed is 8, and then x to the 1/2. I'm going to leave it as x to the 1/2 for now so that I can combine things. Now what you should do is have 1 representative factor of each type. 1 x factor, 1 y factor, and 1 numeric factor, either in the top and bottom or just in the top or the bottom. So let's Let's go ahead and combine the numbers first. I have a 9, a 2, and an 8. Now remember, you could go straight across and go 9 times 2 and get 18. Then 18, 8 simplifies to something. But in the spirit of being just mentally faster and more efficient, we should always look to divide before we multiply, right? Go small before you go big. So 2 8s actually is what? 1/4. So we end up with 9/4. And then you don't have to worry about simplifying 18 8s. 9/4, 9 and 4 are co-prime. So our one representative number is 9/4. Now look at the x's. I have x factors that I can combine. And so x squared divided by x to the 1/2, that's going to be x to the what? 2 minus a half is 3/2. And then I only have one y, which is y squared. So there it is. There's your answer. And if you wanted, you could put the x back under the radical, square root of x cubed. And you're done. So that's one way to get to the answer. Condense it and then combine like factors. If you would prefer, you could have actually completely expanded this and then combine like terms and then condense. But that's a little bit more of a scenic route. All right? So it doesn't have to be completely expanded in order to condense it. But it is worth taking multiple steps when you're condensing. Expanding, not so much. Condensing, multiple steps. All right, questions on that one? Fun or fun? Number 2, right. I don't even know how many funs that was, but probably not enough. Okay, today is Tuesday already. Precal test is tentatively scheduled for next week. That's the 24th. And that's the same day as the math club meeting after school, which will be 4:05 till question mark. Starting today after school, Mrs. Lincoln is going to be going over the test number 4, the Q&A from the test 4 that's on my website, SAT. So if y'all want to come for that, tomorrow will be number 5, and then Thursday number 6. Okay, in her room. All right, example 7. Says to use the properties of logs to evaluate the following. Now, evaluate means to come up with the equivalent expression for the expression that's given. And if you notice, expression A, there are no variables in it. So it's a number. That is some number. Could be some guy's jersey number. What we want to do is decipher that for the person sitting next to us at the game. Like, I don't want to call it log base 4 of 2 plus log base 4 of 32 every time when I want to cheer for that guy. So what is that equivalent to? And I'm like, let me help you. Let me help you evaluate that. That's what you get for showing up to a math competition, though. I mean, what did you expect, dude? Oh, I thought this was a basketball game. All right. Log base 4 of 2 plus log base 4 of 32. Without a calculator, which that's what this one is, I expect you to be able to simplify that using the properties of logs. And there's a lot of different ways to get to the right answer. Would anyone like to share your insight to how we could evaluate that? What's that? Multiply. The 2 and the 3? Oh, so condense. Condense, yeah. That's what I would recommend. That's probably the easiest way. We have log base 4 of 2 plus log base 4 of 32. They're both log base 4s. The coefficients are already 1s, and they're both positive. So I can condense. So I'll pull a log base 4 out front. And because they're both positive, the 2 and the 32 get multiplied where, Trevor? In the numerator or denominator? A numerator. Congratulations, you made the recording. All right, 2 times 32. Sweet. Sweet, sweet, sweet. And now we can simplify that, and 2 times 32 is 64. That's already looking better. So you can be kind of like you could tell the guy, oh, yeah, just yell log base 4 of 64 each time. He's like, I still don't know what that means. Why are you being such an, what's the word without being, don't be, a what? A dingus. Don't be a dingus. There you go. That doesn't really help me, dude. I want to know what that's actually equal to more than that. Okay, well, let me explain logs to you. You see, way back in the days of John Napier, and he gets up and walks away. All right, so anyway, what can we do from here? We got a couple ways to do this. Good. Yeah, you can set it equal to x, and you can convert it to exponential, either by going around the world or exponentiating both sides base 4. So you got 4 to the x equals 64, and now you can get the bases the same. Can you write 64 as a power of 4? You should. 4 to the third. And now, because you have the exponents, or I'm sorry, you have the bases the same because it's exponential, which are 1 to 1, you can equate the exponents. So x equals 3. And so that's what that number is. So that expression way up there is equivalent to 3. Now, if you didn't want to set it equal to x, okay, you could get all the way down to here. Actually, let me just let me get rid of this. That certainly works if you still like doing that. And remember, you can exponentiate to get it down to there as well, instead of doing around the world. You could use the properties of logs. Let's say this, right? Log base b of b to the x is just x, right? So if you didn't want to set it equal to x, you could just say that's log base 4 of 4 cubed. And what is log base 4 of 4 to the third? It's just 3. And that reinforces the inverse property of logs and exponentiation. Start with 3, exponentiate at base 4, turn around, log at base 4, you're right back where you started. And so that would keep it as an expression and never turn it into an equation. And remember, if you work straight down, it is implied that there are equal signs all the way down, right? If you work straight down, you don't need to put equal signs, it's implied. Okay? It's almost prettier not to have them, so that everything that precedes or follows is equivalent to the line above and below it. So condensing is probably the quickest, fastest way to do it. But it's not the only way, so let me space back that. Does anyone have another method? Anyone? Could you divide and conquer? Say I have 2 terms, I'm just going to conquer each one separately and combine the results. Yeah, let's do that. Log base 4 of 2, we know what that's equal to, and maybe you're fast at it, right? Can you write 2 as a power of 4? It's the square root of 4, right? So you can write 2 as 4 to the 1/2. And of course, now, what is log base 4 of 4 to the 1/2 equal to? It's 1/2. So you've simplified the first term. Now let's focus on the second term. Log base 4 of 32. Can you write 32 as a power of 4? Not very easily, right? Because it's not a power of 4. But you know that 4 and 32 can both be written as powers of what? 2. So here's another way to do it. You can use the change of base formula. Let's call that log base 2 of 32 over log base 2 of 4. And here's an incentive to use base 2 instead of base e or base 10. And now in the numerator and denominator, we'll do exactly what we just did in the first term. Log base 2 of 32 is log base 2 of 2 to the 5th. And log base 2 of 4 is log base 2 of 2 squared. So now in the numerator, what's log base 2 of 2 to the 5th? 5. And on the bottom, what's log base 2 of 2 squared? 2. So you end up with 5 halves as your second term. And now 1/2 plus 5 halves is 6 halves. And of course, what's 6 halves? 3. So if you ever have to go from left to right, like I ran out of room there, that's where you'll need the equal sign. Some people on tests and quizzes, when they work from left to right, they don't put anything there. And that's wrong. Don't do that. Some people put arrows. Don't put arrows. An arrow means like a next step, a consequence of, not an equality. Some people put commas. Don't do that. Some people put like a 7 in between there, and I'm like, what? Just put an equal sign, okay? It's equal to 3. That's another way to get the answer. Is there yet another way to do it? I sure hope so, right? Because variety is the spice of life, and I like things spicy. What if we left the first one as log base 4 of 2? Then you can write the second one as log base 4 of 2 to the what? That's right, 5th. And now, using the properties of logs, what can I do with the 5? Bring it out front. That was my favorite property. And now look what we have here. I have 1 log base 4 of 2, plus I wrote 2 instead of a 5. I'll fix it. Plus 5 of those. So I have 1 of those plus 5 of those. Those are called like terms because they're like logs. So what's 1 of those plus 5 of those? How many do I have of those? I like your sense of humor. I think we have 6 of those. Maybe we can scrounge up another one somewhere else. But right now we just have 6. 6 log base 4 of 2. And then you just have to work on log base 4 of 2, which, of course, maybe you realize, oh, that's just a half, because we've done that so many times, and then 6 times a half is 3. So it's another way to do it. So is there a wrong way to eat a Reese's? No. Have y'all seen the commercials? There's no wrong way to eat a Reese's. As long as the thing gets eaten, there's no wrong way to eat it. Okay? Is there a wrong way to do these problems? Yes. Yeah, actually, there's a lot of wrong ways to do the problems. But there's also a lot of right ways to do it. And as long as you get to the right answer, some routes may just be more scenic than others, which is fine. It's fine. Okay. I will tell you, though, that if you know all the properties and you know all about logs, you have more options. You have more possibilities. But if all you have as a tool is a hammer, then you got to start making everything you look at appear to be a nail, right? And you're limited. You're limited. I only got hammer, so I hammer things. But we need a screwdriver here. I hammer screw in. You can, but it's not the best tool for the job, right? It makes extracting the screw a little harder if someone has a screwdriver, right? You can't sand a board with a hammer, right? I guess you can rub it on there for a long time. Whatever. The point is that the more tools you have, you can choose wisely and you can do things differently. All right, this one here, log base 2 of 80 minus log base 2 of 5, kind of the same idea. I think the easiest thing to do is to condense it first. So they're both ones and negative ones in front. So I'll pull the log base 2 out front. Now I have a positive term and a negative term. So when I have a negative term, I know I'm going to have a denominator, so I'll build the shelf. So the positive term argument goes in the numerator, multiplied in the numerator, and the negative term's argument gets multiplied in the denominator. So I have log base 2 of 80/5. And now, of course, I can simplify. 80 divided by 5 is 16. And now we're almost there. Can you write 16 as a power of 2? Sure, it's 2 to the 4th. And now, using the properties of logs, instead of calling it x and going around the world, what is log base 2 of 2 to the blob? It's just the blob, and in this case, the blob is 4. So condensing is, when you can do it, is the easier way, simply because it's the quickest, fastest way to get multiple terms that may have individual logs down to a single log term. And that's the whole beauty of the condensing part. All right, so there's A and B. Now, it says to avoid these common errors when working with logs. If you ever buy like a new wood chipper, you go through the catalog, there's always that picture of that guy who's like falling into the wood chipper and he's all bent up. And then there's that, right? I'm not going to draw that picture, but it says, oh, okay, great. So there go my plans. I was going to do that, but it says not to do that. I guess that doesn't work. That's not good for the wood chipper. Whatever. So when you buy those manuals, which people very seldom read, there's always don't do this, don't do this. So sometimes it's nice to see what doesn't work instead of just what does work. So here are 4 common mistakes that students make, and I'm here to tell you these don't work. If you have the log of a sum or a difference, you cannot distribute the log into its own argument. It does not work. And we already had that conversation up above. You cannot distribute a log into its own argument. If it's multiple terms, this is it. Unless you use the change of base formula just to change the bases, this is your final answer. You're done. And that's because this over here does equal something, but it's not what's on the left. This one would equal natural log of b, or log base b of the product xy. All right? So that's what this is equal to. So you cannot distribute a log into its own argument. Now, having said that, here's what we're going to be doing in the near future. If you have something like log base b of x, and you're distributing it into something like 3 plus a, you can distribute the entire log into some other factor. That could be 3 log base b of x plus a log base b of x. But in that case, you're distributing the entire log into another binomial factor. And you are not distributing the log into its own argument. Okay? So this would be allowed. That would not be. All right, the next one. If you have log base b of x raised to the 8th power, you cannot bring the a out front. Why? Yeah, that a is an exponent on the entire log. So what you actually have here is log base b of x times log base b of x times log base b of x a times. Okay, you have a factors of the entire log. All right, over here, if you were to condense that, that would be log base b of x to the 8th power. So it's only when the argument has a single factor to some power that you can bring it out in front. Here's another one that students like to try. If you have the quotient of logs, they like to try to condense it into the log of a quotient. No, it doesn't work. This is pretty much as good as it gets unless you try to use the change of base formula. It's because this one on this side expands into a difference. And then finally, the last one here, and we talked about this one. If you bring this n out front here, it is wrong because that n is not a exponent on the a, only on the n. So you would have to expand this first. All right, we'll finish the notes tomorrow, and we'll quiz tomorrow.